It sounds like a stock Cummins.
That's a stock Cummins right there.
He probably sits down to go to the bathroom.
220 horsepower. He's a squatter.
He's a squatter.
But this truck is not a squatter.
No! The giveaway truck, 800 horsepower. Oh.
Oh, it's got some low.
Oh, he's got to tap the throttle, make it sound cool.
Yeah, he got first. That was not real low.
That's the lope mod where you just whack the throttle to try to make the governor bounce.
It's good mod. It's good mod.
Okay, so we're giving away an 800 horsepower truck, but that presents a problem. How reliable is a stock Cummins when you're trying to put 800 horsepower through it regularly?
It's not going to last very long. You'll be on the side of the road pretty dang quick.
Blown head gasket, your pistons will scuff because they're too tight.
Too tight. The ring's going to butt.
The cam gear will walk off.
Your crank's going to move all over because the bottom end's just not going to handle. So, what is needed to go into an 800 horsepower reliable street ripper?
Reliable is a full build.
Yes.
So we took a factory Cummins block,
Yep.
machined it, standard bore. So we want all the cylinder wall strength in case somebody decides to really lean on this later.
Yeah. So let's go through. So what does a guy need who wants 800 horsepower on the street? Let's go through the build. So if a guy wants to do this at his house, here's what we can do. And for those guys who are getting their tickets into this entry, you're going to know exactly what's in your engine. It's going to be sweet. So, start off. What's so cool about this thing?
So first thing is, whenever you're doing this, you need more piston to wall clearance. So the block's got to go to the machine shop.
Yes.
You can't just dingleberry hone that at home. You've got to open this up.
Yeah.
So we've opened this clear up to 10 thousandths piston to wall clearance. Pretty standard for this 800 plus horsepower level that we go. Now, unlike Todd's UCC truck, we're way bigger. We're up there, quite a bit bigger. So 10's not excessive and crazy, but it is
up there,
healthy.
Yes. Now you get a 400,000 mile engine, you're going to have that much piston wall just from wear. But on this one, starting fresh, you'll make it so when you get in the power, it's knocking the pistons. They're going to get bigger with heat. That's just the reality. So you got to have room for those things to grow and not scuff the cylinder walls. And so you got to make room for that. Also, the rings got to be fixed. You can't do it in stock rings.
Yeah, you got to. So we file fit the rings and open up that top ring gap. And if you look in a Cummins manual, it says 26 thousandths max. Well, it's bigger than that.
Yeah.
So
we have butted rings at much higher specs than that. So
we've maybe even butted rings at 40 thousandths before. Depends on how much
how
power you put
and stuff.
This one's not that big, but anyway, so you got to do the rings, and then the coolest part of this whole thing is we dropped a 6.7 crank in there to make this thing a stroker.
Yeah, to drop in a 6.7 crank, you can't just set it in and say good to go. You had to do a few modifications. We actually had to take the block and clearance it, which is fairly typical. I mean, in the gas world, stroker engines are everywhere. 383. I mean, the 400
and they've got instructions: grind here,
grind there,
modify the cylinder skirt here, there. So
this was actually pretty minimal. The modifications compared to a typical stroker motor, just a few things on some of the boss casting for the bolt holes from the external, feed is all it was. It really wasn't that much grinding and fixing on the block, but it had to have some modifications.
So why do we even want a stroker? 2 reasons. Longer stroke generally gives you more torque, and torque is fun on the street. And 2, more displacement, spools up turbos faster.
Absolutely, quicker spool up for sure.
The third benefit that we're getting out of this, because the stroke is 80 thousandths taller, that means the piston's coming up 80. The piston will not clear the head, so we've got to cut some off the piston. But essentially, this makes the piston bowl act as if it was a shallower piston bowl. This raises the compression ratio of the engine. Compression ratio has 2 benefits. Usually the engine's more efficient, and generally, what does it do for the power?
It goes up.
It goes up.
As long as you can not blow it up, the more compression, the better. And that's just the reality. I mean, the big powers are low compression, but that's for reliability. More power usually follows higher compression.
So, and then the third, just little side benefit, you raise the compression, things spool faster. So this should be a spooling monster.
Yeah.
But let's be honest, we're not going to give away an 800 horsepower smoke bomb. We're going to give away a fast spooling, well-tuned,
it's gonna be awesome.
800 horsepower. We're going to show you what a 12 valve should be that you're going to street drive at 800, not some slop together sled pulling engine that you street drive a little bit. This is designed so that you can enjoy it.
So the pistons that are going into this engine are actually a Molly Power Pack piston. These are a very high performance piston. I've used these in Frankenstein up to 1,300 horsepower in the past. They're a high power piston. They're great because they have a steel ringland at the top, so it's a total street friendly piston. Most forged pistons are going to give you 20,000 miles in the street.
And they're done.
They're done. It's because the top ringland wears out because they're aluminum. Now there's some new stuff coming out that is cool, but a proven 1,000 horsepower piston Molly power pack is there all day long. It has the coated skirts.
The only thing I don't love about them on some engines is they have made the bolt bigger to handle that higher power level and that big timing, but that lowers the compression a little.
We fixed that.
However, we fixed that with the stroker.
That's right.
So we've made, basically, this is the best street race hot rod piston that you can get and have reliability. I mean, obviously you can get forged pistons however you want them, but you can't get the street mileage out of them.
Not the long-term average. So the pistons should be awesome on this.
So we took the pistons, we had to fly cut them about 80 thousandths because that's what you need to, if you increase the stroke 80. And then we also had to fly cut some valve reliefs in there because we're running a bigger cam.
What's the cam that's going in this bad boy?
So we're running a 188 220 cam in here.
This is a proven cam. It's been on for years. I mean, it's worked really well on
like
a lot of vehicles.
We love this cam. It's from Hamilton. I've ran one in my race truck. I'm building a new engine for my street truck. It's the cam I'm putting in. It's just a very good
all-around cam.
All-around high performance.
Yeah, I mean, it's not gonna be the cam in like a UCC type, 2,000 horsepower truck, but 1,000 horsepower around there, very street friendly. Not gonna kill your spool. It's not so.
Yeah,
lazy.
I don't think you could pick a better cam at that power level. Like if you have a 200 horsepower towing truck, the 188 220 is not what I would recommend. It's not like it's gonna be bad, but it's just not as good as it could be. But at this level, this is by far my favorite cam for this build.
Yep.
So we've got that. We've got the crank in there. So we end up at 6.1 liters. A lot of guys say, why isn't it 6.4? Just a quick lesson. If you take a 6.7 bore size on a 5.9 stroke, you end up with 6.4. You go the other way, a 5.9 bore size with a 6.7 Cummins stroke, which is 4.88 inches, you end up with 6.1 liters. So
there you go. That's the math.
That's the math. If you want a 6.2 liter to make fun of those old Chevy guys, then you need a 40 over 5.9 with a 6.7. You will be there. Yeah. But if you don't trust me, do the math. 4.015 bore times a 4.88 stroke times 6 cylinders, and do the math, and you'll see it's 6.1 liters.
That's right. So on this, with this level, we're lucky that the 12 valve is blessed with awesome rods, awesome forged rods from the factory. They have been proven to 1,000 horsepower and thousands of builds over the years. They are capable. If you hit it with nitrous, if the guy hits it hard, they could bend it.
At low RPM where they make the big torque, it's actually not even a horsepower limit. It's really a
torque limit.
A torque. You get about 22 to 2,400 foot-pounds, usually 2,200 to the tire, and you'll start bending factory rods.
Yep. But you're not. This should be fine at that level. I don't think we're going to approach that. That's more of like a 1,500 horsepower.
Yeah, we anticipate this is going to be in that 1,800 foot-pound range if I had to throw my guess right now.
Yeah.
Till we get on the dyno, we'll see. But that'd be where, so like I said, you still have some safety factor there. And, if it continues to make 1,800 foot-pounds at 4,500 RPM, it could foreseeably make, 1,500 horsepower.
Yes.
You just can't make that big torque. But to help it, we do upgrade the rod bolts. So this has those L19 rod bolts that we sell a lot of. They're from Hazley Machine, and they're great.
Yeah, they're really good. We also, on the bottom end, we got ARP studs, main studs. And that's going to really button up the bottom end. I mean, honestly, that's a short block. We got the Molly power packs. Everything is pretty normal. Going up top, we have our stage 1 ported head. This is our new head we just released.
Our stage 2 is what we put on there with the bigger valves,
this
right?
This is the stage 2.
Yes.
Yeah, so this thing, we'll get some flow charts. We'll look at the flow charts on the website. This thing flows amazingly well.
So we just released the stage 1. Well, we kind of alluded to the fact the difference really between our stage 1 and stage 2 is the size of the valve.
Yeah.
But the port job is complemented with a bigger valve. But the stage 1 still flows a ton. It's a great head, but we wanted to kind of go over the top and release this new stage 2 head.
Yeah.
So it has a stage 2 head. Head gasket's a big problem. Stock truck will never hold 800. It blows the head gasket. So we're fire ringing it.
Yes, so this has got firings cut in the block on this one. If you have the choice to cut firings in the block or the head, generally I like it in the block because it's a higher probability you're replacing the head and not the block. So if you're firing the head and it cracks, it breaks, it wears out, you're going to have to pay for that service again. If you're firing the block, you can just swap out a head on there. Now the big power, we'll do half and half the block, half in the head for ultimate reliability. But for this power level, firing either head or block is plenty. We put in a block, so should something ever happen, the guy can just put a new head on this and not have to pay for that service again.
So obviously it's got a firing gasket to go with it. It's got awesome valve train on that head. And finally, you've got to fasten that head down. So this.
Well, before you do that, what is the valve? You said valve train. What's the valve train? The valve springs. These are our conical valve springs.
Yes, these are our street conical.
Yeah, so this is not so. We have a race conical and a street conical. This is the street that's not so aggressive. The reason we did that because the race one's so aggressive, it can wear a cam out, wear the bushings out. I mean, it's truly a race spring. It's not I wouldn't put hundreds of thousands of miles on it, but these springs are still good to 5,000, 5,500 RPM, not a problem.
And they're not going to overload the cam unnecessarily.
Or the bushings and the bore.
Like race blocks have bushings in the block. These ones are just
the bore.
Just the factory cast
bushing.
block and the one bushing in the front. And so you got to be a little more conservative with your spring pressure for long-term reliability. Short-term, you can get away with almost anything for a few thousand miles.
Yeah.
So.
But then you said it's the fastest for the head studs. What do we use on this one?
So then IFG has these brand new 12 valve head studs. So guess what? We're going to put the IFGs on it. We did that one test on the mud truck and they held up fine.
These are equivalent to like an ARP 625. A lot more affordable. Since we're giving this away, we're trying to save money where we can. But we've had great luck with these. With these nice, they're a nickel coat or some kind of nice coating. They're beautiful, and we've had great luck with them. So this is going to be a good head stud for this thing.
So that, and then did you want to talk at all about the manifolds or anything?
Yeah, anything engine-wise. So we got the pump.
Pump, yes. You can't get there with the factory pump. 800 horsepower is not going to happen.
Don't care what pump you come with. It needs to come off.
So we did our power-driven stage 4, which is a max effort 215 pump, 5,000 RPM governor springs.
Yeah.
And right about a 600 cc pump. And 600 cc's is going to give you more than enough fuel for that power level. But when you're building pumps, you might as well get what you can out of what you have.
Yeah, so that pump is. We wanted to keep a 12 millimeter for this truck because if you go up to the 13, they get really smoky, really hazy. They're harder to start, and it's just not necessary for the power level. I mean, there's a lot of 800 horsepower 13 millimeter trucks out there. That's a case of some guy buying parts he didn't need. If you want 800 horsepower, the truck will behave much better with the 12 mil pump. If you want to go well over 1,000 horsepower, that's when you start thinking about 13.
We get a lot of guys asking about lines. If you want your truck to lope, put big lines on it. If not, factory lines are
sufficient.
A perfect factory designed match for a 12 millimeter pump.
It's like they're engineered to match or something.
They work great. You put great big lines on there. If you want your truck to lope, go for it. We don't want this truck to lope and be obnoxious.
This is a sleeper.
You can't be sitting there at the stoplight going boop, 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 boop.
It's got to sound like a normal truck, and then when you put the foot down, you destroy everybody. That's the goal of Agnes. All go, no show. Agnes. So anyway, so that's the long and short of an 800 horsepower engine. I mean, this thing has got it. This thing should be dead nuts reliable.
Are you excited? I want this.
I can't wait to drive this thing. It's going to be a freaking rip because all the stuff we're doing to it, single cab, long bed, this isn't going to be light. This is going to be just silly fast. It's going to be a fun truck.
And we built you a good foundation there where if you want to grow with the truck a little bit, I think you could get it to 1,000 pretty easy when we get done with it.
I wouldn't be surprised.
But we can't be sending 1,000 horsepower trucks out when we tell guys 800. That'd be misleading. We wouldn't want to do that.
I'm excited to get this thing the dyno's done, and I'll be shocked if we don't surpass our goal because let's be honest, sometimes we go overboard, and this is not an exception. The turbos are well beyond capable of 800, and the fueling system should be too. So
to remember, the contest ends May 15th,
Yes.
so get your entries in now. Every purchase,
every dollar
is
a ticket.
is an entry into this giveaway. So I mean, if you don't even drive a diesel truck, buy a shirt or hat or sticker, whatever the heck you want. Get your entries, and if you do drive a diesel truck, by all means get what you need to make your current truck fast and get those entries.
That's right. Anyway, 800 horsepower, that's the engine. I hope you enjoyed the build. Hope you enjoyed watching it. We're going to do a lot more videos showing the build. We got a lot of fun stuff coming up, so make sure to stay tuned, and we'll see you next time.
Thanks, guys.